Hey everybody, this is Larry. This is me over Q4 of the bi-weekly contest 149. Minimum cost, good caption. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. Apparently a lot of people did very well. I mean, I did okay, but my time is a little bit deceptive in that a lot of time was spent on converting the code from Python to Java. Took about, well, I guess only 6 minutes, but 4 wrong answers, so but still I had a lot of silly mistakes, but that's fine. I think the tricky part is going over the problem. I want to say that there are probably a lot of different ways to solve this, but in terms of different variations on the same thing, but this is my version of the dynamic programming. Dynamic programming and greedy is how I would like to construct this. You could probably maybe do it with path reconstruction, but I think that's a little bit trickier for this one, right? So there are 2 parts for this one. One is to solve the problem to get the min, and then now that you have the min, construct the lexicographically smallest one. So those are the 2 different problems you might, and even though they're very related, yeah, you have to be very careful. And I spent a good amount of time making silly mistakes, honestly. Okay, let's focus on the dynamic programming first, and yeah. And basically, the states that we want to think about for this one, and just to kind of give you a little bit of a warning or a heads up, is that this is a Q4. This is a problem where 33,000 people maybe take a peek at least 4,000, 5,000 people sent, or sorry, 2,000 people submitted it, and only 213 accepted, right? Or 189 accepted, I suppose. Actually, I was looking at the wrong one. So with that being said, the reason why I bring that up is not to make you feel bad or anything, but this problem does require, as a prerequisite, a grasp of dynamic programming. So feel free to just practice dynamic programming before this. This video is probably not necessarily meant for a beginner. I mean, you can watch it just to feel out the vibes, but my focus is to kind of get people to be able to solve it, hopefully anyway. And so and not just so that you feel good about yourself necessarily. So yeah, that being said, so I'm going to skip some basic dynamic programming explanations and just go straight to the states, right? So the states here, the first thing to note is that the 3 consecutive thing, right? So that's the first thing that jumped at me, was that this 3 consecutive means that you're kind of forced in a way, right? So if you choose a character, you basically choose that character for the next 3 occurrences. There are a couple of ways to kind of handle this, but that's one thing to keep in mind. And you can also imagine that it goes 3 and then 4 and then so forth. So you have to handle all those cases in a good way, right? That's one. I think that's actually mostly it, and then it's just about case analysis, right? N is reasonably big, but not super big, so but this is so I do use some this idea with dynamic programming. I don't know if it's super necessary, but this idea of dynamic programming over for loops, right? And what do I mean by that? So okay, so let's go over. So this is the function that we should care about for now, right? And it basically has 3 dimension. You have index, which is from 0 to n. I think this is at this point should be pretty clear. Last is the last character to match. That also, it could be 1 of 26, right? So 0 to 26 maybe. And then left is how many forced characters do we have left, right? So it could be 2, 1, 0, right? That's it. And those are the dimensions, and we just kind of, on the back of the envelope do math. N is 50,000, is it? Right? So 50,000 times 3 times 26, it's 4 million, which is already a little bit slow or a little bit large, but we have to be careful, right? And the reason why I say that is because then now, if you have a for loop that loops every 26 characters, then this is going to be way too slow. That's already, is that 101 million things, which is, right? So that's why we have to do some tricksy things. But yeah, so okay, let's go over the case analysis, right? Which is a big part of most, or a lot of dynamic programming problems anyway, most at this level. If left is greater than 0, right, then we have no choice. We have to convert the current character to the last character that we've seen, and that's it, right? So we have the best, and then just a recursive function on the next index, kept the same character, and then one fewer things that we're forced to have, and then this is just the cost, right, to kind of go up or down, right? And there's no wraparounds in this one, which kind of makes it interesting, but I think it doesn't actually change anything other than a cost function, but just something to think about, right? Okay, so we do have a choice. What happens, right? So we can continue the last anyways, right? So that's this one, which is that we have all the required ones, but we want to stay the same, so we just kind of go that way. You can imagine that we have like AAA, and the next letter is maybe B, and then maybe AAA. We go, okay, well this B, let's just make it A anyway, so then we make it an A. So then what are the states? Well, index goes by 1, that goes pretty straightforward, right? The last character is last. Oof. Sorry, I kicked a little bit and hurt my. I have a hurt foot. So yikes, and I kind of stopped it a little bit. And anyway, all right, my fault. So index plus 1, right? So this is saying, okay, let's change and start at this index, right? So okay, let's start a new streak. Is it a streak? I forgot what they call it, but a streak starting with this character, right? So that's basically it. So that's what this one does. And actually, the reason why this looks, why is my, sorry, in a little bit of a random pain. And the reason why, and these two loops are a little bit awkward, but what I want to do anyway, is to write something like this, right? So for x in range from 0 to 26, right? Go index plus 1, x 2 plus absolute value of c of index minus x, right? So that's basically what we want to do. But the thing is that if you have this for loop like this, it would cost the entire state to times by 26, right? Which is not what you want. Which is not what you want, right? That's too slow. And if you just do a naive like plus 1 minus 1 on the x, well, that's also not what you want, because then now you have a cyclic thing, right? You go up and then down and up and down and up and down. Well, that's obviously not ideal. So okay, so that's basically the idea, right? So we want to do this for everything. Basically, start a new streak with x, right? And here we brute force to 26. So what I did instead is I do a thing. I don't know what it's called. Maybe that someone has a fancy name for it. But I wouldn't say I invented myself, but I just kind of came up at some point, which is just loop unrolling, which I call it loop unrolling because it's very similar to it's very similar to how back in the day when you have a loop and you unroll the things one by one, but instead it is the dynamic programming version of it, which is that, okay, well, here we have this, right? So we want to separate it out to two different things, right? And the way to visualize this, you may say, is just that if you have, you have an array of 26 elements, maybe, right? So I'm just gonna, I don't know if this is, whatever, like some numbers, right? They're not zeros, but I'm just bagging zeros because I'm lazy, right? And let's say you're here, right? And then now you want to check out these numbers, and you also want to check out these numbers. So then now you just recursively check, okay, well, it's this number or this number plus this suffix, right? Almost like a prefix sum construction. So that's basically the idea behind these two helper functions. I call it GoA for aggregation, and that's really it. And one for going to the left, and the other one for going to the right, or incrementing and decrementing. Hence the 1 and +1, which is what I have here, right? And this is very straightforward. It just makes sure that the next number is going to be between 0 and 25 inclusive, right? And this is the thing where if it is inclusive, then you go to the next digit as well. Otherwise, or next character. Otherwise, you take the min of this thing, and then you store it on a cache, right? Excuse me. So you memorize. That's pretty much it, really. Yeah. So, and that's it, right? So now basically the combination of these two statements and this memorization will give us this for loop, right? And kind of just to go over the complexity real quick, this is 0 to n. C is, of course, 0 to 25, the characters, right? And direction can only be -1 and 1, right? So this allows the sum of all the type of these aggregations to be pretty cheap, which ends up being dominated by this anyway, so we don't have to worry about it. But yeah, so that's basically the idea here. And this idea I call it, like I said, loop dynamic programming unrolling or whatever. Loop unrolling. So feel free to use it, and it comes up here and there, maybe not super often, but once in a while, right? And then now I just kind of to kick it off, we know that we have to start the first character. So instead of using kick it off by using go, which I was trying to write a for loop for, but then I realized that I'm just ending up doing a for loop like this anyway, so that's why I have this thing, right? So I start at the initial character from the first index, counting down. Oh, sorry. One more thing is that there is a +1 here, in case you're wondering. I maybe this part I went too fast, but +1 because that's +1 to shift to the new C, right? So yeah. So here we just start from the first character going up and then going down. Take the min, and then this is the best. So this is now gives us the minimal characters that we have to change so that it fits this criteria, right? And if it's greater than or equal to infinity, we return empty string. And then now reconstruction is actually pretty okay as well. We don't need these. I guess here you could also just return a bit, but I feel like that's like maybe a smell. But in any case, so yeah, so this part is the second part of it, which is to return the lexicographic problem, right? So we know what best is. So the idea here is construct a thing such that, okay, moves we've seen so far plus prospective move, meaning the move that we want to make, plus the new state's cost is equal to best, right? So that's basically the idea. The moves we've seen so far is the past. Prospective move is the move that we are going to make. And then the new state's cost is if we make the move, how much does the rest of the move cost? Or like what's the best case scenario for the rest of the moves? And if that equals to best, then we are on a good, then we want to make this, right? And the only thing that is left is that you have to loop in such a way that you match the lexicographically smallest. We call it that very quickly. Lexicographically smallest means that you should be greedy as early as you can. The reason being that you can think, the way that I think about it is actually easier with numbers, right? If you have 0, 0, 0, 0, or maybe even 0, 0, 9, 9, 9, 9, 9, 9, 9, right? You have a lot of nines, but it doesn't matter because this number still comes before 1 with a lot of zeros at the end, right? So this is the same logic as if you have like A, Z, 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 and B, A, right? The A still comes first, And so you want to see if that's the way that you can do it. And that's basically the rest of this part, even though I think when I wrote this, I had some off by 1 because I was just not thinking correctly. But yeah, but basically special case for the first character. I guess you can also just write cost 0, 0, but yeah. But this is the perspective cost. This is set the first character to X, right? So if we first set the first character to X, this is the cost. This is going to be the rest of the new state's cost, right? Because you're starting by X. You have index 1 and you have 2 characters left. And so if that's equal to best, and keeping in mind that best is the minimum, right? So you can only go to the best in any case. You cannot do better than best by definition. Otherwise, something has gone really wrong somewhere along the line, right? It should be just by definition. So if this is the case, and because we're sorting it already from the smallest first, the first character that we run into will be the answer. So we append it to the answer. We add it to the cost. Remember, this is the moves we've seen so far, cost, and then we break. And then now, for the rest of the string, it's the same idea, right? We just go through it, the last character. And this actually have a very similar thing to kind of just this thing, which is my naming and intended. Because the first time I did it, I had a silly mistake. You can watch the live portion and see what I did. But yeah, so the last character is just going to be answer -1. So left is equal to 2. We have 2 forces left. If left is greater than 0, we just add it to the cost. Left -1, answer append last, and that's it, right? And keeping in mind that all these forced things, they're factored in here, right? So yeah, and they're factored into there via this way. So, you know, everything is consistent. Okay, so what if we have a choice, right? So this is, we have no choice because we already know what the last character is and how many characters that we have to do to meet that 3 minimum. So then if we don't do that, then we have, you know, just try every character, right? Okay, we are now free to try every character. And yeah, and basically there are only 2 cases, right? So if the character we want to try is equal to the last character, then the thing is that we don't have to have a new requirement, right? So it stays at 0, keeping in mind that the else implies that the left is already at 0. We have no more requirements for the last character. So then if this thing, the cost, and keeping in mind that, I mean, and you can imagine it, right? In that if you have 0, this will always give you a better answer than 2 or equal to, because you just have more freedom, right? So yeah, so basically this is the cost that we already incurred so far. This is the cost from X, oh sorry, the other way around, from the current index to X. And then this is the rest of the state where this is 0. That's the key part. And if that's the case, then we use X. Otherwise, we want to start a new character, and the new character with X. And this is everything's the same, right? Pretty much, because this is the cost, this is the prospective cost, and this is the cost for the rest of the new states. And keeping in mind that you have to now have a new requirement of 2, and then your best. Right, so if that's equal to best, then this is a good enough path to go. Again, it doesn't matter whether, like, it may be less ideal to continue from the previous to start a new one, right? As long as the best is cost, it's fine. And it could go, for example, if you have like, I don't know, DDD, I don't know, XAA, maybe in this case, it makes sense to go from X to A, right? Oops. Even though, I mean, I don't know if this is true. Okay, maybe another one is like CBB, right? So it makes sense to go from C to B, even though maybe CDD, maybe. I don't know. Whatever it is, it just makes sense for it to start a new one, right? Even though you could have continued the old one. I don't know. That example was actually kind of bad, but you get my idea anyway. So that's why it doesn't matter which path you go, or it only matters what the current character is for lexicographically smallest, and that's basically the idea. And again, if everything holds, then there should be a path, and that's why I had a assert false. If you go for 26 characters, then you can find an answer. And then at the end, you join them all together, and that's it. This complexity is just a for loop, right? So this is n times 26 at most. I mean, roughly speaking, because obviously you cannot change every time, but you know, yeah. But and this is all of 26 as well. This one, of course, we only do 4 operations or 1 lookup operations. So this is O of n times alpha times 3, which is just alpha times n. And this one is even smaller, right? It's also alpha times n, except for times 2. Actually, I guess it's not that much smaller. But in any case, yeah. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Definitely a very hard problem. Very make it easy to make mistakes. But yeah, let me go over or show you the code from top to bottom real quick. This is the top. This is the aggregation function. This is the standard dynamic programming. Standard, but it's not that easy, as you know. As you I mean, sometimes I say that it is standard, but you could watch me live during the video, so you could see how I solved it and whether that is actually that standard. But yeah, and then this is just to reconstruct a way to get back to it. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching. Time to take a nap. I'll see y'all later and take care. And you can watch me solve it live during the contest now. Good. Oof. Honestly, harder than it seems to get it precise. I mean, wow, that took 15 minutes. It's sad. And I'm cheating a little bit in that I see the difficulty for Q4, but we'll see. Only 213 people got it though. I'm not super worried, but let's see. You're given a caption of length n. A good caption is every character 3 consecutive times. A good caption is a string where every character appears in group of at least 3 consecutive. Okay, at least 3 consecutive. Okay, you have operations. Shift before, shift after. Okay. Okay, so it's not just the amount. You want the answer, which is actually very annoying. Okay, let's see. Whew, okay. How would I want to do it? Okay, I guess you binary search and then greedy, if I have to guess. Binary search to figure out the smallest amount. And then greedy it down. How would you binary search? What? N is big-ish. 'DP' is there DP? DP states are reasonable, I suppose, because it's just every character and whether it has 3 or less. Right. Okay, let's do the DP part to get the min. I think that's maybe straightforward for me. You have index, you have the last character, and you have left to do, right? So then if index is equal to n, we're done. If left is equal to 0, then we return 0, otherwise we return infinity and beyond. Okay, then now you have what is that? 50,000 times 26 is 1,000,000 times that should be fine. No, because then if you want to do Actually, is it easy? Because you can have a thing where you have AZZ, but then as a result, you would actually want to do it this way because it only takes one operation. Oh, no, you don't. There's no wraparound. Okay, so no, and that's not a possible case. So then the only case you ever want to do do you ever want to go up? I guess so. If you have CDD, you want to go D, right? So then how would you create a dynamic programming thing? Is it binary search? Complexities in my head are a little bit slower. I mean, these are straightforward to do, kind of. When do you ever go up and go down? I need to use the restroom, and I'm limping, so I'm gonna be a little bit slow. BRB, I'm just thinking in my head. Okay. Okay. All right. I think I got it. I got it. Okay. So what I needed to do is one more thing. So the thing that I was thinking about is that you converting this to a DAG, right? But you can go up or down, which kind of makes a cycle if you're not careful. But the thing is that you can also just add a direction thing to kind of for loop it, right? And that should be fine. So that's 26 times 3 times that times 3 should be fine, right? So, okay. So if left is greater than 0, then we have no choice. Have to convert to last, right? Yeah. So then the cost is equal to what am I doing? No. What I want is caption or C is equal to A for A in caption minus, okay. Right, so then last would be a number, and then now, okay, we have to convert to last, so that is just the absolute value of last, a C index minus last, so that's the cost, and then we go index plus 1, last, left minus 1, 0 is the direction, plus this, right? Okay. Oops. I already have infinity. Oh, yeah, F min. Okay, right? Otherwise, if left is 0, we can convert to last. Actually, I guess then we could take this out. But then if left is equal to 0, then we have a choice to go up or down. Right? So go up. Okay, if direction is greater than 0, then we can choose to go up or down. And this is just so that actually I didn't. This is actually just 1 because we want to change it. This is go up. This is go down. But only if okay, we have no choice, we convert to the last. This is a little bit awkward. I mean, okay, I think I wrote this wrong anyway. I think I had it right before. I mean, it's fundamentally close, but this part is not the same. It is 0. And then this is just staying the same. This is last plus 1. This is last minus 1. And this is and last minus 1 is greater than equal to 0. And last plus 1 is less than or equal to 25. And then this thing would just be plus 1. And this will be actually plus 0. And then now we turn best, right? Kicking it off is a little bit awkward. But it's fine. go 0. Oh no, go 1 I. You have 1 letter, so you have 2 left. Oh wait, also this is coming to last. Is this right? No. This is actually C sub I. I'm dumb. Right? Now left is going to be 2. Yeah, okay, and then this is this is I'm doing this wrong. Okay, no, this is way wrong. But okay. Convert to last, okay. Otherwise we start our own thing. This part is fine. But you also want to brute force going up. Right? But we want to do it in a way such that I think I just need another function. Maybe that's the thing. Index character direction. Right. So then and that will sum up all of it. Okay, fine. Go index plus 1. C sub I. Go A for aggregation, and then 1, and then -1, right? So what this will do then is if C plus direction, if this is true, then we also want to do go index. Oh no. C plus direction, and then sum of the answer of index C to start. It's this plus 1, but yeah. 2 to left, and then divert. This direction is not needed in this case anymore. I think I just kind of did it because then now, well, this is a different function, but okay. So is this? This allows to go up and down on the same index. And I think this is index plus, well, no, this is index, but we'll call it index plus 1. Okay. But we actually don't need this because it's duplicate, but that's fine. Okay. So then now we want to do, yeah, okay, the first character. Oh, really? We just go we can do the first index. Well, that's not the answer yet, so because we have to return a string. C sub I is index. Okay, well that's not great, but it's a start. This is actually right, but here is not right. Why? This would just be this. Actually, that one I felt like it should be. Well, unless this part is very wrong. Which it might be. So first index, C, direction. Don't know. Index, last character. Let's look at the ACA case, maybe that's a little bit interesting. Oh, they're just all zeros. Does that never return index is equal to n? Okay, it does, but left is never a zero. Or should we just here? We have no choice to convert. I'm so confused. Left minus 1. Am I just off by 1 or something? Let's also just focus on this one for now. Looking at a clock, but it's not a real clock. I have 40 minutes left. 25, 2, 25, 1. But that means that this should be 0, right? Oh yeah, no. And it should return 0, so then why doesn't it? Am I being silly? So it does return 0. Huh? Did I mess this up? Yep, I don't know how fmin works. That's what happens when you type both things. I typed it so many times, but it's still clearly possible to make a mistake here. Okay, so 2 is the right answer. Okay, that is the right answer, what we're looking for. I can't believe I have to debug that, but okay, but this is not possible, they think. Oh, okay, so we can actually keep on. Oh, this is only if okay, yeah, I didn't keep the case where if last is equal to C index, then you can also I mean, in this case it'll be 0, so it's just keep doing it. Okay, so this gives me 2, which is right. Okay, good, right? So now we have the answer. Okay, so we have the answer. Then the question is, how do we construct the how do we reconstruct the thing? I think you just take a digit at a time in a greedy way. Right? Yeah. Okay, so then now we have answer, right? So then for I in range of n, okay, I've got to keep track of the states, right? So yeah, so then if go I x yeah, I think the first one is a little bit awkward, but okay, so okay, just do it differently, Larry. Okay, stop trying to generalize it. Okay, so if go sub 1 of x of 2 is equal to best, then answer append x, we break. Right, okay. So then now what happens? Then now we want to say yeah, that's fine. The first one will get you the first character. Okay. Okay, so then now we start with last is equal to 2, right? And then now let's go to accurate index just to be clear. And then now we can do if go index x. Okay, so there's no choice, right? So, and then the cost, I guess the current cost is equal to whatever, we can figure it out. And then here, if last is greater than 0, then we transist by C of index minus last. So cost we increment by this, and then that's it, right? Else we have to take out which path we took, right? And also decrement, whoops. And also append last, yep. Otherwise we have to figure out which one we took. So if last is equal to, no, you have to go from 1 by 1 in a greedy kind of way, right? You can't just go by order. Okay, so 26, right? So if last is equal to C of, or if last is equal to X, then what happens? Last equal to X, then we can this cost is a little bit awkward actually. This cost so far, right? And the reason is because we need it here. If last is equal to X, then and then we just go, if go of index last 0 is equal to cost plus best, then this is the good path to take. And so we don't update last. We append x as the answer, or last really. The cost, same cost, and that's it. Yeah, because x is equal to last. Otherwise, we're converting it to last, right? So, okay, so, okay, and then here we break because we got a thing. Okay, otherwise, if goal of index of x2, this cost is not quite right. Is this cost plus this plus best? Cost is the prefix cost, so then you have this plus this, right? Okay. So if converting it to x is equal to this, but it's not that. It is not last. It is starting a new character, so it's x. So okay, so it's the cost plus this plus best. Oh no, this is a little bit. I did this wrong. This is wrong. This is wrong. This is the cost. That's the rest of the cost. That's the pre-cost. That's the current cost for the cost. So I should be on the other side. What am I doing? Okay, but better late than never, hopefully. Okay, if that's the case, then we just go this way, and this is right. And that's it, I guess. Yeah, I guess that's it. That was assert force for not getting the answer. And then, yeah. Oh, answer would be, so we have to convert it back to something like that. Assertion force. Why is that? Wouldn't one of these ends have to be right? Yeah, let's actually print this one instead. More readable for Larry. Alright. So we have 2. We have BA. It thinks that B can be an answer. Why? Well, that is why this isn't working, but oh, I didn't update last here. Also, this is just wrong. It's not minus last. Oh, well, I'm confusing a couple of things. There's left and last. Last is equal to answer minus 1. Left is equal to 2, and I confused them. Wow, that is pretty bad. Left is equal to 2. Okay, maybe try this again. Well, that's not great. Isn't that what this is supposed to do? Index 1, x, plus, or is this plus, Yeah, I even did this well, but so this is the conversion, and then you get it. Okay, this is right, and then here. Many silly things. Assertion still false, but for this one, okay. I mean, it thinks it's AA, which is not great. Why does this think this is the case? Best is 2, right? Okay, so it converts. That's already wrong, right? I think for CD, it just skips stuff. All right, let's just look at it one at a time because I'm confusing some print statements. I think this is DDDD, which is actually not great. Why does this not print? X is... Oh, it doesn't print because... So if it's C... Okay, so this is giving me infinity for a lot of stuff, which is also not right. Huh? Huh? So at index, oh no, A, B, C, C is no good. Why is it? It doesn't. I mean, that shouldn't be, right? Like, it's good that we have the answer, or an answer, but it's not the answer. How much time do I have left? I have 25 minutes. I should be able to do this. I don't know why I'm struggling so hard. Okay, so this one C. This is one for this part, really. Let's take a look if this is right. Okay, so that's right, but adding this makes it wrong. Because, so let's say we have CCC. CCC, so then you either start a new one. Oh, this is... Oh, all these are starting new ones, so we don't continue the streak except for here. And that's actually not intentional. Actually, yeah, I think I did that one wrong. Okay. Oops. Or like, it should not have... We want to continue maybe anyway. So, okay. Okay. A. And the last one should be A. Right? Do I mess up last and left again? Possible. left with 0 here. We want either continue. If last is less than x, then we are continuing. But we can also start anew, but starting anew just means this thing, right? No, but this doesn't even make sense because you have no choice, so it's this part. Oh, this is left. Okay. We have no choice. Okay, that's fine. CCC, and then the last one we have D. So we try C, we try D maybe, and no good. We convert it all to X. That's for. It's just that we convert to last, then we don't have to start a new thing. Because then now we have 0. Oh, this is a pending last for some reason. When it should be a pending X. Yeah, I guess this should be an X anyway. But then we have to update last, so that's why last is equal to X. Okay, so let's just say this part is okay. What? Okay, so it should be here. Last is C, yep, X. Okay, so this looks okay. Starting a new thing, right? Am I off by 1 on the index? I am, because it's index plus 1, that's why. Alright. I mean, I don't know, because BB is clearly not the right answer, but that may just be an impossible case, right? Because infinity, yeah. I guess it'll be wrong anyway. I don't know. Sometimes I like to take it out. I don't know how I feel about it. Is this right? All right. That's actually unfortunate. That's actually unfortunate. I forgot about the class clearing anyway, but classic Leetcode things. Let's try again. I don't know if that fixes it, the memory limit thing, honestly. It is classic Leetcode things. I mean, we were borderline anyway, but it is classic Leetcode things. I'll convert this to Java or something. Okay, fine. See, it's just that it's impossible to debug, right? Like, you don't know how much memory you're using. You can't test it. For 712 to 714, and maybe I can also do go a.cache clear. I actually forgot about. You can say I'm sloppy, but I don't even know if that's technically true. It's just that Leetcode is kind of terrible. Right? Like, should I need to be able to have to do this? I don't know. I don't think so. like this problem is hard enough. I don't know. Maybe there's a cleaner solution. There are some people doing it in Python, which is time limited. Great. Oops. Yeah, we had one more solution, but like you take a look at this and you're like, okay, I don't know, right? Like this, is it fast? No. Does it work? Okay, right? Now it's giving me memory limited. I hate Leetcode and these things. We have 18 minutes. I'm asking ChatGPT to write it in Java for me. Which is like a really crappy thing, but I don't know. I don't think my math is right. Maybe my math is wrong on the complexity. Does that look good? All right, let's give a YOLO submit. I don't know the answer to these, I suppose, so. Oh, okay, yeah. I don't know how Leetcode, I mean, ChatGPT kind of gave me the wrong answer here and screwed me. Maybe there's an int and long thing. They're all longs. I mean, this works in Python. I didn't really double check. I guess I could. I was looking at only the longer ones and didn't look at this one, but how does this happen? I mean, so it's in this part. Actually, this one got. I don't think I wrote that. But okay, fine. Why, huh? That took me a long time to debug that part though, which is actually also sad in either case. But I don't get it. No, wrong language. I mean, there's something wrong with either the caching or something. This is so stupid. It's probably not great. Something, I mean, yeah. I mean, yeah, when you see negative numbers, it's not great. Okay, that looks more reasonable, and now it's giving me the right answer. So I guess my choice of infinity is not good in Java, which, you know, that's fine. All right, let's go. Please. I mean, I don't know, like, we had 4 wrong answers, but all of them are because of Python versus Java. Not gonna lie, I'm gonna sneak peek real quick to see what people did in Python. I mean, this is basically the same as mine. It's just that they did it top down or bottoms up, which is like a really silly thing to need to do. You ask me. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, the explanation, this video, the contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.